Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of PG Mustard, and this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, how are you doing today?
Hello, doing great. Just returned to California for a long trip, a long flight. But doing great. How are you?
I am also well, just recovering from our hottest day ever in the UK yesterday.
Yeah. I've tried to watch some online. I was tired of movies and tried to watch some news and so on. And the BBC, 95% of time was talking about this weather records, right? So, yeah.
Yeah. Well, you're used to it in California, right? But we're getting used to it now. Anyway,
yeah,
getting there. Wonderful. So today you chose the topic. What is it we're going to be talking about and why?
We are going to talk about various kinds of indexes. Particularly, we are talking like BRIN indexes, so block range indexes. And because recently we had a few materials published, I think it's good. Also, discussion on Hacker News, so it's a good time probably to discuss and various aspects in our experience as well, right?
Yeah, absolutely. I'm very interested in this, and as you mentioned, there was a recent blog post. I thought it was by Paul Ramsey at Crunchy Data, and I was lucky enough to be able to see a talk at Postgres London by Thomas Vondra about some of the improvements.
So you was let me repeat the thoughts I expressed last time. I think all conferences should start recording. This is my position. I haven't responded to Postgres EU yet, but unfortunately I'm going to say I won't go to attend to present my talk. I probably will join for panel. We'll see. It mostly depends on my wife, and if she will travel to me to Berlin, we will go. So this is because I've got invitation to discuss Postgres upgrade topic on some panel discussion. So, but in terms of my personal materials, as I've said already, I'm going only to attend conferences which record. I think it's very important to present to a wider audience because not everyone can travel, and also it's just much more efficient if you present to offline audience and you have good connection to them and follow up discussions after your talk. But also if you have recorded material, this is like forever. It's published, and you can refer to your previous materials, and you can also see some mistakes you've made and fix later and so on. It's very, very, very it's like next level. And I saw how other conferences outside Postgres community did it during many years. And I wanted to emphasize that it's also beneficial for conference itself, because these cloud of materials accumulated over years, it attracts even more attention to the conference and it increases the value. So I think conferences which don't record, they shouldn't exist anymore at some point. This is my strong belief. So I already, as I've said, in San Jose, I made an announcement that I'm not going to present anymore if conference is not providing recording. So I'm glad that you was Thomas Vondra, right? You were there.
Yes, yes,
and you saw it. But we have slides. We don't have video, unfortunately, right?
Yes, good point. Yeah. We did find he was great. He is great, and he published his slides. I'm not actually 100% sure it's the exact slides from Postgres London, but I think he's given this talk a couple of times, so it's from one of them.
Mm-hmm. I hope he will give it one more time online. I already asked to invite him to Postgres TV Open Talks series, so I hope we will have a recording. If he accepts, it would be great. Let's see later.
Wonderful. Anyone listening, that will be on Postgres TV if it's
right. So we have Postgres FM, Postgres TV. Quite easy to remember, right? And since we discussed it, these two names, everyone please subscribe and help us to grow. What can help? Of course, if you subscribe can help, and also if you share links to Postgres FM to particular episodes or just to Postgres FM web page, in your social networks and groups where you discuss Postgres or engineering in general. It will be very, very helpful for us to grow. So please do it.
Brilliant. Well, so block range indexes. So we have our default index type. If I just create an index in Postgres, it will create a B tree, which is the default. Great default. It's got a lot of benefits. It's brilliant. But we do have other options, and one of those is Brin.
Speaking of B-tree, it's in almost everyone. I think in every database system, it's default. Mm-hmm. And this is my favorite question, but also like very tricky question, because I know when you interview some engineer, it's like you feel it's quite good engineer, but if you like pull this question out of your set of prepared questions, like what's B-tree, and let's discuss the structure and balancing. In many cases, interview is over, unfortunately. So because like if you hear balanced, it's okay, but if you hear binary tree, it's interview is over, right? So I think every engineer should know it, but there are many engineers who don't know, unfortunately, what B-tree is. But B-tree, of course, is a standard de facto for database systems. Right, but it's not enough in many cases, and people try to find, or it's like not enough in terms like of performance, and B-tree can degrade over time quite like a lot, or it can be big one, right, in terms of like size occupied, and also like when you talk about size, it's not only disk space occupied, but also part of buffer pool, the cache state. So if index is huge, it means you need to your buffer pool needs to keep more pages, more buffers in the pool, right? But yeah, I just wanted to provide some remarks about B-tree, because also like some meta remark additionally. We have got very good feedback. Thank you for everyone for feedback. It's very important for us to hear like what you think about our show and the ideas. And we also like got couple of guys mentioned that we like quite basic material, right? Let's do some more hardcore. But I'm 100% sure that there are many people who need basic material. So I think we need continue to talk about some basics, but sometimes trying to go deeper, of course, right? So that's why I talk about B-tree, because like if it jumps straight to Brin, well, B-tree is default, so it's important to understand how it works.
Well, and Brin is quite advanced, I would say. I think a lot of people can go a long way using Postgres, and there's not a sensible case for using Brin, or there's no need to know about it for a long time. And you mentioned already a few of the times where B-trees can get cumbersome, and I think the big one here is size. Just raw, if you've got a like a very, very large table and you're indexing a column on it, it can be a very, very large index.
And index bloat.
Yep, absolutely. And then the other thing that got brought up by Paul Ramsey in his blog post, which I hadn't actually considered before, was that there can be a difference in write overhead. So B-tree having a higher write overhead on average than some other index types. So that's one other final downside.
Yeah, this famous index write amplification, one of the reasons Uber went from Postgres to MySQL, right? So each time we updated a row, all indexes should be updated unless it's hot update. So it's a big problem, of course. So if we have just one index, it's just one update additionally to the heap update. But if we have 10 indexes, we need to overhead becomes bigger and bigger. That's why you need to get rid of unused indexes and redundant indexes, right?
Yeah, but the one thing I really hadn't considered was that different index types could have massively different overheads to one another, and that
well, it's very common, for example, to have issues with updating of Gin. There are special options like fast update and so on. So Gin updates are very heavy, expensive. But B-tree, like it's like medium level of overhead in terms of updates, of course. But Brin is definitely like light,
super low,
super low, right?
Awesome. So I think, but do you think it's fair to say that the biggest advantage of Brin indexes is their size? So that they're at least an order of magnitude, often 2 orders of magnitude smaller than a than a B-tree index.
Well, right. So if you don't know about B-tree, you should definitely start with Wikipedia as soon as possible if you consider yourself an engineer, right? But what is Brin index? It's like quite simple structure which describes which like in B-tree pages we have links to tuples, but not direct for each tuple, but for ranges. So we describe like this page in heap has tuples starting from this ID or timestamp or something, starting with this number till this number. So everything in between is there. And of course, multiple pages can be referenced in this way, and you can control how many. By default, it's 128 pages can be referenced for one range, but it can be adjusted. So in this case, like interesting here is that this index directly dictates you that like you should think about physical layout. Because B-tree directly doesn't do it, right? So of course we know that if, for example, you have some value and or range, and B-tree says that these tuples are located in that heap pages, and for example, we have 1,000 tuples, and each one is in separate page, so 1,000 pages. It's called like sparse storage. You can run a cluster command and reorganize your heap so the storage will be according to this index, right? And in this case, probably they will all go to a few pages. So fetching such tuples will be extremely fast compared to this sparse storage. But Brin index directly says I'm useful only if your tuples in heap are stored sequentially according to ID or timestamp. So in this case, for a particular range, only a few pages will be referenced, right?
So it's the way I've heard it described is it's all about correlation, and if they're exactly in order, 100% correlated, it's optimal, and you can get really good performance there because the index can be used to filter out the vast majority of the blocks from being scanned, and it only has to look at a small number. But as it gets less correlated, performance degrades, and if there are some exceptions, and it makes the ranges wider than they ideally should be, it can degrade quite quickly.
And overlapping also.
Yes.
Overlapping, so, right. So like, okay, but yeah, not overlapping, but the same range can be used many times because more than 128 pages are referenced for this range, so like it's not good. But like, how can we check the physical storage aspects? There is a hidden column called CTID. You cannot create a column called CTID, right? Because it's a system name, it's reserved. But what CTID is, it's two numbers. One number is page number, and second number is offset inside page. First number is the most important, and there is a trick how to extract it for like various, I don't know, like to count distinct number of pages for particular rows. It's easy. You can convert it to point and then extract only first. Like to point, I mean xy, right? And then you can take only first argument, and in this case you will get only page. This is how you can extract only page number from CTID. So you can check your data always and check what CTIDs or just page numbers with this trick You can check and you can see exactly if you can see this correlation, right? So if you have sequential ID used or timestamp, which is filled by some like now, or better in this case clock timestamp, because now is generated only in the beginning of transaction. So if you insert, you have some batch insert 1,000 rows, all of them will have the same now value, but clock timestamp will generate timestamp for each row inserted, right? And you will have difference in values, right? And in this case, you can just check, select CTID, convert it to point, and get first argument, and then ID or credit at, and you can see if there is correlation. Or I think you can even apply some functions to prove that correlation is strong, right?
But
maybe
the cases I hear,
good exercise.
The cases I hear about this are like people actually using these in the real world tend to be cases where you're pretty sure it's correlated already because you've been inserting timestamp data in order, you know, maybe it's a sensor reporting data, and you never update it, you never delete it, it's all going in order, and you can
delete is okay. Delete is okay.
Good
Only
point,
update matters.
Yeah. So those cases, you don't have to check that it's like you can check for sure, but equally that's the case where it's most likely to be relevant, or at least until the latest version. I think those cases were pretty much the only good use case for Brim when you had
append-only tables.
Exactly.
Right.
And
let me describe once more. I'm trying to as I've said, some basics to describe some basics. So once you've learned what CTID is, I recommend you to create some table with surrogate primary key, like sequentially some generated number or some like sequence, and then for example, we have a row where ID is 1, and we see that it's inside page 0 with set 0. Okay, but then I recommend you to execute update this table set ID equals ID where ID equals 1 and see what happens with CTID. This is very interesting because it may be unexpected for you, because you will see that CTID value changes. Sometimes page is the same if there is space inside the page, but you see how tuple, which is a raw version, physical raw version, is generated, new tuple generated always, even if you logically didn't do like ID equals ID means we don't do anything, right? But you see how tuple is generated. That's why updates can shuffle your data, right? You can have correlation can be worse over time.
Yes. So let's do an example where if I have some really old data and maybe I found out the sensor was incorrect or it had a bug in it and some of the data needs to be updated. If I update some of that old data,
right?
What Postgres will really do is insert new rows at the bottom of the heap. And then mark
in some pages where there is a space.
Yes, good point. Left. Yeah, good point. But not
if you deleted something.
Yes,
for example.
But then that reduces the correlation of that table.
Exactly.
Brilliant.
Yeah, or also we have some import of old data we are missing. Let's also not update, but insert can be a problem as well. If we insert old data, like postponed insert, right? Delete is not a problem. I don't see problem with deletes, but postponed inserts and updates. And also, you know what? Probably a problem repacking. If you run pgrepack allows you to achieve the same effect as cluster, but without downtime, not blocking for long. Right. So if some DBAs, for example, didn't notice that there is a Brin index which requires this correlation with physical storage and values, and decided to perform repacking using pgrepack or pgsequalize. I'm not sure if pgsequalize supports this, but use clustering according to some another column or index. You will get very different physical storage, and correlation will be not good at all in terms for your Brin index.
Interesting.
Right?
I thought PG Repack would help, but when you said, I think, have you heard of PG Squeeze? I think that's the one I'm aware of that's an alternative to PG Repack.
I'd
be interested in those.
PG Squeeze, I've read about it, checked it, but I mean, I didn't use it yet. It's interesting idea to use logical decoding for instead of this PG Repack approach with like substitution of table. Like it's a really interesting idea with delta table, right? So PG Repack writes all changes in some delta table, and then sometimes it's a challenge to apply it because a delta changes from this delta table should be applied, need to be applied in a single transaction. So if a lot of changes are accumulated, it can be a problem. But if you use repacking with cluster option, using different, for example, you may have I don't know, like some name column, right, alphabetical, and you want to reorganize your heap to extract, like you have pages. You need to present the data with pagination ordered by name, and you think this is the most useful use case for you, so you decided to reorganize heap, so the data in heap is ordered according name. So there is correlation with name, not with ID or created at timestamp. Your Brin in this case will perform not
unless it's a Brin on name,
right?
But I've actually thought of a problem with delete as well. Once you've deleted those rows let's say in the middle of your heap, and it's vacuumed later, new inserts are now going to go in the middle. So now we've got a problem again.
Point.
But anyway, so
good point. Good point.
I agree. This is interesting because I think it slightly takes us on to the improvements that Thomas was talking about in Postgres 14. Sorry, do you want to go back?
Because we discussed this.
Yes, let's do that.
Yeah. So yeah, just to make some conclusion before we discuss improvements in Postgres 14. So it means that before Postgres 14, Brin can be used only if you definitely have append-only pattern for your table, like log-like table. You log some events or some data from some telemetry data from somewhere and so on. Right. In this case, Brin can be useful.
Or it degrades quickly and you need to reindex regularly. Like I guess there are some use cases if you do update data and then reindex, I guess you have some benefits still. But it degrades quickly and maybe there isn't the benefits. Maybe you're better off with B-tree.
Hold on. Can reindex help? Like clustering can help. So you need to organize heap.
Maybe maybe repacking and then reindexing or clustering them.
Maybe this is interesting. Do we need the reindexing? But it's light anyway.
Yes.
Yeah. It's very light.
But they were popular.
That
use case is not lots of people have logging tables. Lots of people do have this, at least for one table.
Yeah, but the problem is I've tried at least 3 times over a few last years since Brin popped up, was created. Never decided to go with Brin. Never.
Interesting.
I don't know. I didn't find it useful. The size of it is quite small, but it always, on large volumes of data, it always performed worse than B-tree for me. Much worse. Maybe because I had these materials, both materials we mentioned, and we will provide links in description. They both mentioned that for point searches, like when you need only one row or a couple of rows, Brin is not attractive. Maybe I had closer to this, or I needed only 20 rows for pagination and so on. But when you need to find many rows, like thousands of rows, Brin can outperform B-tree. I always, when I need to decide what I should use, I do experiments. I'm like huge fan of. I'm building company on top of idea of experimenting with always for learning, for making decision. So I always and it's the best case if you can experiment with production data or like similar to production without PII, without personal data. But I never decided to use Brin because I saw them less performant.
That's
compared to B3, even without even for update only tables, only inserts.
I'm the same. I've only ever seen B-tree outperform Brin in terms of raw query performance. I think there's a good example in the Crunchy Data blog post where in lab conditions Brin can outperform B-tree, but in the real world,
I have let me to have some disclaimer. Last time I was like a bad cop guy who criticized a lot of various stuff. I'm going to continue. So I see value in criticism, but I'm going to be like polite, maybe sometimes not very polite, but because I often have some opinion, quite strong opinion, right? But I hope nobody will be offended, and it's just for improving things, not for damage, right? And I also can be sometimes very wrong, and I quickly admit it if I see evidence that I'm wrong. But in this case, I want to criticize both materials from Paul Ramsey and Thomas Vondra. I cannot understand how we can talk about performance and physical layout and so on and provide plans without buffers. It's a huge mistake, like simply huge mistake, because we discuss how Brin can be more better in terms of performance than B-tree and talk about some timing, which is have a lot of like it's back and forth. I mean it has fluctuations, right? And it's not reliable. At least you need to run it multiple times and take some average if you talk about timing. So and also Paul Ramsey's blog post also makes some conclusions based only just from a single point of data. For example, like 10 rows, 100 rows, 1,000 rows, 10,000 rows. Okay, we see Brin is better. Well, like, I'm not convinced. I'm not convinced because I saw for huge, and also like million rows. Seriously, million rows is nothing today. Yeah. Test at least with billion rows, right? So sorry for maybe I'm offensive, but it's so like I just want everyone to have better materials. It's great to discuss performance, but don't do plans of explain analyze. Do plans with explain analyze buffers. We will see I/O. I/O is most important. All indexes are needed to reduce number of I/O operations. Index is all about reducing I/O. Any index. We want instead of making like a lot of buffer hits and reads, we want to have a few buffer reads and hits to fetch 1 or 1,000 rows. We don't want to have million hits and reads when we need only 1,000 of rows. But when you talk timing, I don't understand where this timing comes from. When I see buffers, I understand, oh, this timing goes from a huge reads and buffer reads and hits numbers.
Yeah. Really good point. Right. And I think actually there's a couple more. So the reason I was always, I always used to think until the blog post and until a couple of things that Thomas said, I always thought Brin couldn't outperform B-tree because it only has the ability to do bitmap heap scans or bitmap scans in general. And so a B-tree can also do a bitmap scan. So the only slight advantage is that you have to build the bitmap if you're using a B-tree. So there's slight overhead there for the B-tree, but it's also efficient. So it's looking at exactly the blocks it needs, whereas
When you say you need to build it, you mean you as executor?
Like the PostScript, yeah. No, sorry, yes.
Not the user, not user.
But I was thinking
right.
the executor has to for the B-tree index, but it doesn't have to for the Brin index. But with a Brin index, I think you'd always get false positives back that you have to filter out. Like you're always going to get some rows on those blocks that you're going to then have to get rid of. So I didn't understand how it could be more efficient. But anyway. But the main advantage I always thought was the size. So if you can have, instead of having a multi-gigabyte index that also then takes up multiple gigabytes in the cache and all those things, you could have an index that's normally in the kilobytes, or even for very large tables in the megabytes. So that I always saw that as the main advantage rather than performance.
You know, if for example, if we just created a table, filled it with data, and forgot to run vacuum, and I see a crunchy blog post Plexit, in this case you will have the plan with bitmap index scan, right? And in this case, I can imagine that Brin will be efficient if you have huge table and you need to find and fetch a lot of rows. Should be there, but like I would definitely look first of all on like a type of operation like bitmap index scan, and also I would look at buffer.
I've just remembered. Yeah, I agree. One last thing that's a bit unfair with the crunch data blog post, and I know it makes it a slightly fairer comparison, but it's unfair in the real world, is that they also disabled index only scans because Brin doesn't support them. So make it a more apples to apples comparison. That's disabled, but in the real world, you might sometimes get an index-only scan, especially for data that isn't changing.
Yeah, Michael, you were supposed to be a good cop here. Why?
I didn't agree to this.
Why you?
I'm teasing.
Okay.
Yes, but yeah.
Okay.
Those are all really good points. I'm really happy that we've brought those up. Also, I actually do think they're good content, and I'm glad that they're sparking a discussion here. The other thing, that if we're on the more advanced side, I do think Brin has improved a lot in the last version. I didn't know that I wasn't aware of how much it had until Thomas's talk. The one thing I really wanted to bring people's attention to is a new operator class, which I'm aware is slightly advanced, but by default, Brin indexes still behave pretty much exactly as they did in Postgres 13 and 12, I believe. But if you change a setting while you're creating the index, if you create it slightly differently using there's a couple of different new operator classes, but the one I'm particularly excited about is min-max multi. And my understanding of that, and this might be flawed, is that instead of only maintaining a single minimum and maximum for each block range, it can instead maintain multiple minimum maximums. Now, the big advantage of that, so two big advantages are it can support different types of correlation. So if there are, if your data's oddly, maybe not the timestamp example, but actually timestamp example is great. If we inserted some old data, we would now be able to have two min maxes, or probably not two, probably lots more than that, but we could have the new data and the old data and a big gap in the middle where Postgres knows it doesn't have any data for that big gap. So at worst, they degrade much less badly, but I think it's a huge improvement that could support a lot of different types of correlation as well. And I'm interested why. Well, I think it could be so useful that it should be the new default for Brin. But I do understand that defaults are difficult to change, and you might not want to affect existing users.
To me, it sounds like a game changer change. Game changer change.
I like that.
Sorry for. And like I'm looking forward to testing it once again. Unfortunately, I still don't have any real big production with Postgres 14. But once I have it next time, for me, it's a reset of my opinion about Brin indexes. So, because as I've said in the past, they like I made decisions not go, and I like next time I would probably not spend any time, not waste this time double checking. But now I definitely will double check for the cases when this correlation is not perfect, and we have some not intensive, but like occasional updates or deletes or postpone inserts as we discussed. It sounds interesting, and I also see like to be fair, Paul Ramsey's article doesn't describe these improvements, but it talks about pages per range option that was available before already, and you can try to play with this parameter and see how your performance in your particular case is affected negatively or positively. And also mentions PG StatTuple extension to check like physical layout of pages and see what's happening under the hood. This is very, very good. I mean, to remind about these capabilities, this is helpful if you run your own experiments. So good thing. But Thomas Vondra discussing improvements also shows some good examples, and I've noticed that these operator classes, it looks like they are available for various types of data types, right? And UUID is there. This is interesting because UUID is usually considered as like randomly physical distribution is awful, right? And BRIN for UUID is not good because you have like
some.
It's not
I
ordered.
think there are some UUID versions that
there are some.
I'm wondering if that's why they've been included.
Yeah, actually we use it. I now remember we use some allocation in our tool. We use some almost ordered, right? But many versions are not like UUID V3, V4. I don't remember these things. They don't look ordered at all. And this is interesting to check how new improved BRIN index can perform on this data type. So not only it should be interesting for cases which not fully update only pattern, but also for these kind of data types.
In person, actually, Thomas made a really good point about this is actually a really good area for new people that want to contribute to Postgres to explore. He has got a few ideas of improving these further, and indexing in general is quite an isolated part of the code base. You don't have to understand everything about Postgres to be able to improve things. And BRIN indexes especially, they're isolated. They're not the default, so they're not as contentious. So I think there's a few good reasons why this would be a good area to get involved in. And I think Thomas mentioned being willing to help people out if they do want to get started on that kind of thing. So that would be awesome.
Good first issue.
Yeah, right. The label.
Right? If Postgres used GitHub or GitLab, it would be this label would be there in this issue. But
definitely a topic for another day.
Postgres doesn't use. Yes. Oh, yeah. We have several topics like that. Yeah. Good. So I find these two materials useful, like for like reminding that you can use this in your experiments or that. But as I've said, I'm a big fan of experiments. I think everyone should experiment with their own data and queries. Like if you need to make decision, don't trust blog posts blindly. Experiment with your data and your queries. Think about even if you don't have data, you can generate some like as close as you think about future and also queries, and then you can
absolutely. My big piece there is always to make sure you have roughly the right number of rows. That's by like everything else matters a bit, but then the raw number of rows in the right order of magnitude makes a big difference to which query plans you're going to see and to overall performance. So if you do nothing else, please at least insert an appropriate number of rows for testing.
And I need to add here, on two sides, number of rows on two sides. First number of rows stored in table, and second number of rows you need for your query. Sometimes there is no limit in query, and then your data is growing, and this is a big mistake many people often do. So not limiting the result set. So you need to think how many rows your users will need. They won't need probably a million rows if you present these rows on some page on a mobile or web app, right? So you need to think about limit and pagination and so on.
Absolutely. I think we're done.
Yeah, good. Nothing left in this topic, I guess. At least in our heads. Maybe some people have some additional thoughts. I would love to see in comments or in Twitter, probably.
Yeah, and I think we probably could talk about it for a bit more. Like, there's a Bloom, like the new Bloom operator class seemed really interesting, and the min-max thing is also configurable. But I'm also conscious of time, and I think we should I think that probably is verging a little bit advanced. But there's some really cool things happening in Bryn. If you haven't considered them for a while, please do. Upgrade if you can to Postgres 14. What else? I think,
test 15
if
already.
You're brave.
Test Postgres 15.
Also upgrade to 14.4, not
For testing, you don't need to be brave. It's not production. Testing can
very
happen
true
elsewhere, right? So I'm not saying upgrade your production to 15 beta 2. It's probably
brave is not quite the right word, is it? Awesome. Well, thank you everybody for joining us. And send us your feedback. Let us know what you'd like discussed. And thank you, Nikolai. Hope you have a good week.
Thank you, Michael.
See you next week. Bye.
Next week.